Hello viewers, in today's class we are going to discuss one important and conceptual problem from limits, right? And here we see that we have to evaluate this limit, that is limit x tends to 0 plus this positive sign shows that we have to find the right hand limit of this function, and the function is 2 sine, and here we have the fractional part function of x and divided by tan of fractional part of x, right? So the important thing about this limit is that first we have to find the right hand limit at x is equal to 0, and this function involves fractional part function, right? So here we need to know about the concept of fractional part function in order to evaluate this limit, right? So let us start, and here we'll also see that how to write the solution of this problem step by step. Now viewers, here let us first quickly see the definition of fractional part function, right? So the definition of fractional part function is the fractional part of x is given by x minus greatest integer of x, right? So this is the definition of a fractional part of x, and the domain of the fractional part function is the set of all real numbers, right? But the range is given by this interval, that is 0 to 1, right? It means the range of fractional part function is given by this inequality, right? Okay, so once we have seen the definition of fractional part function, we can easily evaluate this limit, right? So let us call this limit as L. Now here see, we have to find the right hand limit of this function when x approaches to 0 from the right of 0, right? It means all the values of x which are approaching towards x equal to 0 are greater than x equal to 0, right? So let us write this limit as by taking the substitution, that is we'll take x, so we'll take x is equal to 0 plus h, right? And the important thing about this quantity h is that h is greater than 0. It means h is a positive quantity, right? And moreover, when x tends to 0, then h tends to 0, right? So here we have taken the substitution, that is x is equal to 0 plus h, because in general if we have a point, say x tending to a plus, that is x tends to a from the right of a, then we always take x is equal to a plus h, right? So here we have x tends to 0 plus, it means a is equal to 0. That's why we have x is equal to 0 plus h, right? Okay, so now let us write this limit L as the limit x tends to 0 plus, and let us write x minus greatest integer of x for this fractional part of x, right? So we have 2 sine, and here we have x minus greatest integer of x, and in the denominator we have tan and x minus greatest integer of x, right? Okay, so now once we have written this step, we can replace x by 0 plus h, and x tends to 0 positive by h tends to 0, right? So now we can write limit h tends to 0, and we have 2 sine, and for this x we have 0 plus h, which is h itself, right? So x is equal to h. So here we have h minus greatest integer of h, and in the denominator we have tan h minus greatest integer of h, right? Okay, so viewers, here we see that now we have this term, that is greatest integer of h, and we have to assign a value to this greatest integer of h when h tends to 0, right? So for this we'll make use of this important expression, that is h greater than 0, but h is very small, right? So h is always greater than 0, but it is less than 1, right? Because h is a positive quantity and it is a very small quantity. So h lies between 0 and 1, and from the definition of greatest integer function we know that if h lies between 0 and 1, then the value of greatest integer of h is always equal to 0, right? So we can also verify it by taking some particular values of h. Let us take h is equal to say 0.0001, right? So the greatest integer of 0.0001 is the greatest integer less than or equal to 0.0001, right? And it is obviously this integer, that is 0, right? So now this limit L takes the form limit h tends to 0, and we have 2 sine, and here we have h, and for greatest integer of h we have 0, and in the denominator we have 10. Here we have h minus 0, right? So now we can write it as limit h tends to 0. This is 2 sine h over 10 h, right? And from trigonometry we can write limit h tends to 0, 2 sine, here we have 2 sine h, and for 10 h we can write sine h over cosine of h, right? Now sine h and sine h get cancelled, and we have limit h tends to 0, and this is 2, and this cosine h will go to the numerator, so we have 2 cos h, right? And when h approaches to 0, we have 2 times cos of 0, and cos of 0 is 1, and this is equal to 2, right? So the right hand limit of this function when x approaches to 0 is equal to 2, right? So viewers, this is how we solve this important limit. And always remember that the concept of function in mathematics is of prime importance, right? Once we are clear about the concepts of different types of functions, we can easily tackle these type of problems.